Hello, welcome to new problem. So today we're going to do this problem called maximum or average subarray. Number 643 on LeetCode. It's an easy problem, so let's get right into it. So it says you are given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. Any answer with a calculation error less than 10 to the negative fifth power will be accepted. That is interesting that they note that, but let's just go ahead and get into the beef of it. So, I want to get the input and output. So let's say that the input, let me read it again. We're given an integer array nums, so nums, which is an int array, and I'm pretty sure k, which is an integer. And then to make a quick note that k is size of subarray. K is size of subarray we need to find. And then the output is length is equal to k. Do I gotta return the subarray or I'll return the value? Okay, so um, return value that has max average sum subarray of size k. Okay, so that's cool. Okay, so I'm kind of getting an image of how to solve this problem. So let me ask some questions, I guess. So, are there any questions that I do have? Do I have any questions? I think I do, but let me just get these notes down here because I like it like that. All right, so some questions that I would ask is, what is size of nums? Um, or what is the min size of nums? And what is the min value of k? I think those are some great questions. So the min size of nums, we can just scroll down, is 1. Okay, is 1. And then the same thing for k2, the min size is also 1. That's cool. So now that we got the questions down, we know the input and output. Let's go through some examples. Let's go through some examples. Example 1. So let's say, let's make it easy, right? So we have an array of 1, 2, 3, 4. Okay. And then k is equal to 1, right? So obviously, we're going to go through the list, trying to figure out which subarray of size 1 has the highest max average value. So it's obviously going to be 4. So we're going to output 4. Okay, now what about example 2, right? We have the same array, but k is equal to 2. So I'm guessing it would work like this. We would go through 1 and 2. We find out that the average is whatever. We can go through 2 and 3, find out the average is whatever. We go to 2, 3, and 4, find out the average. And then we find out that 3 and 4 had the highest average. So we're going to output average of 3 and 4. I don't know what the average is. I'm too lazy. Is it 5, 6, 7? 7 divided by 2, that's like 3. It's like 3.5, 3.5. So yeah. So that's very interesting. But what about an example where I don't want to do an example of the constraints because I feel like that's pretty easy to do. So let's go over. It's pretty easy to like visualize what the min constraints are. Right, it'd just be the first element, right? So what about if we kind of switch it around? So 4, 2, 4, 1, and then 2, 5, right? Um, and then I guess k is equal to 3. Will this work? So this is 8. This is 8. Wait, 5. No, this is 7. And then this is this is 8. Okay, so it'll also be return 8 divided by 2, which is 4, right? 4 meaning that that is the average of these three. And so yeah. Um, okay, so after going through some examples, I do understand the problem a little bit more. So let's go ahead and kind of figure out what tools we can use to solve this. So what I'm thinking about is we're going to use like 2 pointers. So 2 pointers. I'm gonna use 2 pointers. I guess like a left and a right. To kind of keep note of to keep track of where we're going. Um, hmm. Maybe we'll have 2 pointers. I'm not sure how it would work, but that's what I'm guessing right now. And then obviously we have some if statements to compare average, compare max averages. And then we're also going to do a for loop to iterate through nums. And then what else? For loop, we're going to have like a variable to hold, var to hold current max average. And then, yeah, I think that's pretty much it. So yeah, we can get straight into it. Of a plan. I can visualize something that could work. So, first off, we gotta set our. I don't think we need 2 pointers. We just need only. Oh, I was looking at like I thought I had a dash on my screen, but that's just like a little dust thing in my screen. Okay, so plan. The first thing I want to do to kind of solve this problem is I want to initialize cur max average. Max average. And then we can take negatives, right? We can take negatives. So um, I'm just going to get. So I'm going to say that the max average is just negative infinity. I forgot how to do that. But I'm pretty sure I can just do negative infinity. I don't know how to do that. And then we're gonna go through some pointers, I guess. So I guess left. So left pointer is equal to 0. Um, and then left pointer equal to 0. And then what do I want to do? I want to go through a for loop for I in range all the way up to the length of nums. I want to iterate through this. So what will happen is that we're going to go iterate up to k. So hold up. If I is equal to oh no, if I want to compare. So look at sliding window. Okay, so we're gonna see if um if I plus if left plus I um is more than wait, how do I do this? I forgot how to do math. I forgot how to do math. -3? Is it like that? Wait, I'm kind of confused. Hold up. I gotta visualize this actually. Good thing I'm doing this because I know I could have a sliding problem and I could be stuck on this. Okay, I'm kind of stupid right now, but that's fine. Okay, so oops. That is my artificial neural network calculations. Need that. All right, so let's say we have an array, right? Let's just do this example. Oops. I forgot how to calculate this stuff, so my apologies. So let's say we have 4, 3, 1, 5. 4, 2, 1, 5, right? And we want to see, because right now I'm comparing the indexes, right? Um, so this is index 0, next 0, 1, 3, 2, 2, and then is it 3, right? And I want to see whether the bounds, so um can I just do 3 minus 1 or something like that? We'll see. I'm pretty sure I just do like, okay, so if I want to see if this is in bounds of 3, I guess I would have to do like 2 minus 0, right? So I guess I could say like cur window, cur length is equal to I minus L. Does that work? So 2 minus 0 is 0, right? So we can compare. And of course, the length of k is non is starts from 1, right? So we have to do like some like if I minus 0 is equal to the length of that's the length of nums, no, equal to k minus 1, right? I think that would work. Um, so this is okay. So 2 minus 0, that's equal to 2, and that equals to 2, or the length of k minus 1, or k minus 1. And then to move on to the next section, right, which is 3, which is we just move from 0, 1, and 2 all the way to 1, 2, and 3, right? So what we do is we do I minus L. So I minus L, that's 2, right? So it's still 2, and so it does work. Okay. Okay, cool. So look at sliding window. All right. So if it's the case where we confirm our sliding window, then we can check. So if equal size, then check. So to check, we gotta do the max average, right? The max average array. Okay, so what we do is we have the max. We have to hold the max average already. So say res is equal to. Oh, I'm gonna put it to res is equal to negative infinity instead of current max average, right? So okay. So if equal size and check, okay. So we can just check that res is equal to the max of either res or the sum of hmm, okay, yeah, I can do it this way, but it would take more memory and time. But I think this is fine for the first iteration of like how I would actually solve this to make like have the fastest solution, right? So sum of nums at left and I, right? And then divide by k. Yeah, is that right? That's right, divided by k. And this should work. But I think there's a better way to do that, but that's fine. If you go then check, and then in order to kind of go through or like increment, right, as I plus 1, um, hmm, how would I do this? So let's say sliding window, right? We have L, Oh my god, it's so small. It's made it too big. We have L, and then we have I, right? So at this point, right, we know that I is gonna go to the right, okay? And so what happens there? Um, I think at the time that we know that at the time where we do have our sliding window like completely done, then I want to increment I, but um, yeah, I want to increment I. So I want to increment I. So I is just going to go here. And then when we know that I is gonna, so when we know we have the equal and we already did our calculation, right? We're going to say that L left plus equal to 1, right? And so in our next calculation, right, our sliding window is true. It's true still. And we can do the calculation over and over again. But what if that's not the case, right? What if that's not the case? So what if we start from 0, right? So if we start from 0, I think what's going to happen is that left is still going to be 0 no matter what until I is up to the point where we can, oops, where I is up to the point where it equals to the sliding window value. And so I'm pretty sure this should still work. So as I starts from here, right, we don't do anything until we hit here and here, right? So we hit there. Um, and then yeah. One thing that I think I would like to do, kind of make this better, is I want to have like a sum, to have like a sum value. So sum is equal to 0, right? And so we just keep adding sum. Okay. How would this work? So we would add sum. So look at okay, so we would add like sum is equal to nums at I plus equal to 1. No, nums at I, right? And just keep on going. So here we get 4, 6, 7, right? So our sum is 7. And then at this point we're like, okay, so res is equal to the max of res right now, or sum divided by k, okay? Or just random divided by k. And then um, once we do that operation, before we increment left plus 1, we're going to subtract nums at L or left. No, nums. No, we're gonna subtract sum by nums at left, right? So we're already subtracting this, so this doesn't really count anymore. So boom, right? And so now the sum should be 3, okay? But then once we go to the next iteration, right? We move I by 1 to the next one. And then we do see that that the length they're equal. So we do the same thing. Res is equal to the max of. Oh no. We do the same thing where we add into the sum of the I value that we just iterated at. And then yeah, so it's 1, 2, and 3. So that's like 6, right? Yeah, that's definitely no. It's 2, 1, 5. Oops, my bad. So 6, 7, 8. So 8 is the sum now, and then we go through here because it's true, and then we say that the res is equal to the max of res or sum divided by k, and in this case it would be sum divided by k, and then yeah, we're just gonna keep doing this until we can't anymore, And then we should stop there. And then from there, we can, at the end of the for loop, we can just return res. And I'm pretty sure this should work. So it should return the average of um of 8, so which is 4. No, it's not 3.6, which is like 2.7 or something like that. I don't know. So yeah, this makes sense to me. So what's the time we're looking at? 20 minutes. Okay. Um, it's not that bad considering I had to like do this to kind of check, check my stuff. So I think this is fine. So let's go ahead and copy paste this into LeetCode so I can implement. Okay, so I don't want this anymore. Get that away from me. All right, so first things first, all right, in our plan, we wanted to initialize our variables. So res is equal to, is this thing? I don't know. Math dot inf. How do I do that? How to put negative infinity um in Python. Oh, wait, what? Oh, INF? Is it that easy? I don't remember. INF. There's no way, bro. Is it really? Wait, is it really though? Is it really though? Is this true, chat? Like, is this? Um. Oh, it's in Okay, so I can do that. Keep alt tabbing because I'm used to it. Okay. So it is. Okay, so that's cool. I didn't know that's a thing. But I think I like math dot. I don't know. Okay, import math. And I like math dot negative infinity. So math dot inf should work, right? You know, I don't like that. I don't like that. I like float where it's negative inf. I like that better. So does it matter if it's locus or replicas? I don't know. Uh, whatever. Like just like that because it's static, or it's like a variable that wouldn't change. Okay, so it took a while. So now we do left pointer, right? So we got initialize left pointer to equal to 0. So I'm just gonna say L equal to 0. Then sum is equal to 0 for now. And then we're going to iterate through nums. So for my computer's struggling right now for I in range, or to length of nums. Why is it struggling so hard? We're going to add whatever sum we have as we go through the array. And then we're going to look at the sliding window. So look at sliding window. So if it is true that our sliding windows is equal to k, right? If that's true, then we gotta do some operations. So if sliding window valid, then we do this. So I'm gonna check the res is either the current res or the sum that we just calculated. divided by decay to get the average. Or, I mean, and then afterwards, we're going to subtract the sum. We're gonna no, we're gonna subtract nums at L from the sum so we can go forward. So left is now incremented by one index value. And so from there, we should be able to find the maximum average subarray. So we're going to return res from there. And this should work. So I'm just run it. Fail. Did I put left? Oh, I meant L. Okay, accepted. Test. And it works. And it's a very average runtime. And I think that's fine. But yeah, that was a good solution to kind of go over. A good question to go over. So yeah, sliding windows pretty cool. All right.